Okay, welcome everybody to what is going to be a 4-day Wavefront training. The sessions are going to be each day at the same time for 2 hours, and we'll be covering different topics and different things on each day. Hopefully you're seeing the presentation. Let me know if not. I'll cover briefly both today's agenda and a bit of a preview of what we'll be covering on the other days. So today is really the introduction to Wavefront. As far as I know, we have a pretty diverse mix of people on the call. Some of you may be quite familiar with Wavefront already and used it quite a bit. Others, this may be one of your first time seeing the product. So today is really trying to get you familiarized with what Wavefront is, where you can find more help beyond these training sessions, how data gets into Wavefront. That'll be a big focus in the data flow section. How to look for and find your data, which I already know from working with some of the cloud health folks has been a topic of some interest. And then finally, what I would call is a preview to the Wavefront query language. In a lot of ways, the whole Wavefront product is built around its query language. And so it's one of the most vital things to understand well. And with that in mind, while today there'll be a preview of it, really the focus of tomorrow is a deep dive into the query language and all the functions and capabilities that it offers. Day 3 will be focused more on user aspects of the system, like how to really understand what charts are showing you, how to interact with dashboards, how to create and edit dashboards of your own, and things of that nature. And then day 4 is more of the actual like monitoring focused piece, looking in more detail at alerting and events within Wavefront. I'll just pause here and ask any initial questions or things that you would like to see covered over the next 4 days that you're not seeing here. All right, and I'm going to try and pause and ask for questions as we go through this, but please do feel free to make this interactive, especially I would say like tomorrow's session on the query language deep dive. If you come to that with your use cases in mind and things that you want to understand how to make happen, then I'll be very happy to try and do some of those things live with you. And I think having the session be interactive will be of benefit to everyone. Okay, so just quickly, introduction to Wavefront and how you get more help. I'm obviously going to try and provide a lot of information over the next 4 days, but I'm sure that you will have additional questions and want to learn more following that. So I'll just quickly show you where you can find that content. All of the Wavefront help is at docs.wavefront.com. This is actually linked from within the product, so you don't even necessarily have to remember the URL, but it is a simple one. I'm just showing you a preview of what it looks like here. A couple of things that I think are important to note. The search, I found even in my own usage, the search works fairly well for finding things that I want to know. Like later on today, we'll be looking at the Wavefront data format. It's pretty easy to find that and other documentation. I would keep an eye on the release notes. The product aims to ship a new release every 4 weeks. So every 4 weeks or so, you know, those release dates can vary a little bit, but you should see this updating pretty regularly, and I would keep an eye on it to see what new features have come in. Particularly recently, we have been working a lot on our user interface. We're going to be focusing this training on our V2 UI, which is shipped and generally available, but there's lots more features and functions coming to it, both in the next release and upcoming releases. On the doc side as well, there is plenty of video content. Which you can find under videos. Most of these, so the training we're doing this week is multiple 2-hour sessions. Most of these videos are 5 minutes or less. And I found that a lot of users like to start here, especially this intro section, to get a quick flavor of Wavefront. But an interesting aspect of this and around asking us for help is that even internally within VMware, there's a lot of different teams that are using Wavefront. And what has happened a lot in the Slack channel is people will ask for help, but it's not immediately obvious to us which team they're from, what is their Wavefront tenant, what is their Wavefront cluster. If we know that, it's much easier for us to quickly help. We actually do have ways that we can look from your email what Wavefront tenants you have access to. But if you let us know up front, it helps us a lot. So in the case of Cloud Health, there is a dedicated Cloud Health Wavefront cluster called cloudhealth.wavefront.com. So for anyone on that team, if you just say, I'm from the Cloud Health team and I'd like help with this, it makes it obvious to us. Also, if you haven't seen it already, and I'll be showing this directly in the product, it's possible to link to the exact place in the product that you have the question around. We find this comes up particularly with dashboards and charts where you're trying to write a query, you're trying to make some visualization happen and it's not quite working as you expect. You can send us a link directly to that that chart that you're working with. Then we can look at it, hopefully modify it and make it do what you're hoping to do and send you the link back. It makes supporting you that much faster. And the Wavefront team does have access for support purposes to be able to see the charts that you're sending us so that we can help you with it. What this screenshot is actually showing is there is a link button at the top of every dashboard and the top of every chart. This link button has the ability to link to a live version of the chart or a non-live version. It's normally the case that you want the non-live option, like you're trying to show us how this chart looked at this point in time at 12 p.m. on a Tuesday. Here's what the data looked like. Can you help me with that? But from time to time, if you want to link someone to whatever the live data is, you can do that there. There is, in addition to this link, an even quicker one to just hit on the lower right-hand side of each chart or each dashboard that will grab you the non-live link, which is the one you normally want. Okay, so just to level set everyone, because again, I think it's a diverse audience with different amounts of exposure to Wavefront. I'll spend just a little bit of time giving an introduction to what Wavefront is all about. This is a description that we've had for a long time. This is slightly evolved, but this is almost the original description that you would have seen about Wavefront with some tweaks if you had looked at Crunchbase back before Wavefront was acquired by VMware. So it's a SaaS product for ingesting high rates of time series data and then giving you the ability to visualize that data, do analytics on it, and alert over it. One of the things which has been added, of course, to this description is that over time we've added additional data types and capabilities. The training for this week is going to be pretty focused on metrics, on time series data, but Wavefront does support distributions, or also called histograms, and tracing. And I know that within the Cloud Health team, there's actually already some usage of tracing as well. The kind of genesis of Wavefront was from the founders of the company had worked at companies like Google, Twitter, PayPal. All of these organizations had built streaming time series type solutions internally for their monitoring of the the large infrastructure and large application deployments that they had. And the founders of Wavefront wanted to bring that kind of capability to the market so that anyone could use it. And so that's kind of really the genesis of the product. The company existed since 2014 and was acquired by VMware in May of 2017. Many of the Wavefront customers, certainly prior to the VMware acquisition, were SaaS companies, a bit like Cloud Health. Companies like Intuit, Lyft, Groupon, Workday, the Yammer division of Microsoft, and others. Now we're part of VMware. We do have a lot of enterprise customers as well. I'll just give a shout out. I know that some of the PS people that are on the call are working with companies like Freddie Mac, for instance. But really the genesis of this was a SaaS observability platform that was being adopted by other SaaS companies like Cloud Health. And I'll actually jump into a quick little demo now, just to give a brief view of kind of what Wavefront is all about. This is somewhat of a quick end-to-end example of how an on-call engineer might use Wavefront. On the top, and we're looking here at a dashboard. On the top left of this dashboard, I can see something that looks kind of nasty. Like this chart is called transactions per second, and I can see that it's fallen off a cliff. And indeed, there is an alert event highlighted on this chart saying we have this severe alert, aggregate transaction rate too low. So the idea is I'm on call. I got paged essentially by Wavefront. I might have gotten the page through PagerDuty or something like that, but it was Wavefront that triggered the event. And the Wavefront alert said, go and look at this dashboard to try and troubleshoot what's going on. And sure enough, I can see there's a big problem here. A lot of data that you send to Wavefront has tags and dimensions on it. Once you have those tags and dimensions, it's pretty easy to start pivoting by them. So if I, for instance, look and see, is this a customer-specific problem, and switch to pivoting by customer, I can see that it isn't. So I have a bunch of customers here, and they're all dropping off at the same time. So not a customer problem. Maybe it is an infrastructure problem, though. Maybe there's one particular app server or a few that are the problem here. And if I pivot instead by app instance, I see, yes, sure enough, most of them are still fine, but one of them, and I can see on the legend in the lower left part of my screen where app 5 is highlighted, I can see that app 5 is the problem machine here. I can go a little further than this. So I know that app 5 is the problem. Let's see what else I can discover about that. I'm actually going to switch the dashboard to look in more detail at app 5. The chart on the right-hand side here is deliberately noisy. It is set up for demo purposes. But the idea is we're showing all of the metrics that we're collecting about app 5, both the infrastructure that app 5 is running on and metrics from the code itself, the telemetry from the app. And of course, one of those things that we're collecting is the transaction count itself, the thing that was causing this alert to fire in the first place. What I can do is correlate this drop-off against all the other data that we're collecting. And when I do that, it's showing me both positive correlations and inverse correlations of things that are behaving similarly when this transaction rate is dropping. And I can see that at the same time as the transaction rate is dropping, free memory is dropping off. And inverse to that, the amount of errors from our logs is spiking up, and the rate of garbage collection is spiking up. So I can kind of tell this is a problem to do with garbage collection getting out of control on app 5. Maybe that thing needs to be restarted, or maybe there's actually a code issue that needs to be looked into of why memory is problematic on that app. Here's the little link icon I mentioned. So that you can link from the top where you can grab a live one. But what I use mostly, and what I think a lot of users use, is just right here, you can grab a short link to this current time period that we're looking at. I can then share this with any other users so they can see it as well, put it in a ticket or anything like that. Just to highlight something, like say that engineering looks at that bug, they find out what the problem is, they actually ship a code fix. A nice aspect of something like Wavefront is being able to actually verify when your versions change and how those version changes relate to the behavior of the app. I'm mostly showing this example because this is actually the way that Wavefront has monitored versions internally, and we found it to be very helpful, which is we monitor our versions with metrics. What I've seen a lot of times is customers will actually track the version of their code as a point tag or as a dimension on the data that is being emitted. So in this case, we're looking at that transaction rate that was causing the error. We can see where it dropped off, and we can also see here where it recovers and seems to get back to normal. And a lot of times people will actually embed the version here, which does work, but it can be a little fiddly because what that gives you is over time you have multiple different time series as the version changes instead of just a continuous line like we see here. In this demo example, and this is what the Wavefront team does for its own telemetry, we're actually tracking the version at any given point in time as a separate numeric metric. So we can see that all of the apps are on version 107 at this point in time. Most of them have stayed on version 107 because right now we've just pushed out the fix to app 5 to see if, to really see in Wavefront, did that fix the problem before we push the 108 version to the other apps. And so we can see very neatly and clearly when the version changed and compare this version change to any telemetry in the system, even telemetry that doesn't have the version tag on it. It's also possible to ingest events. So we've actually marked here a time-stamped event of when we did that code change. So I hope that made sense. Any questions? All right. I'll just touch on some of the kind of key differentiating aspects of Wavefront and why customers use it, why they adopt it. I think it's mainly about scale of ingesting data and speed of querying the data out. So I think the Cloud Health cluster is currently going at about 250K data points per second coming into it. The largest Wavefront customers are sending on the order of 2 million metrics per second. I'll touch on the data retention part of that. We keep the data that is ingested at its original resolution for, I believe we're keeping it at 25 months currently. Many tools like this that you may have used in the past will roll data up over time. So you might send data every 30 seconds. You might keep that 30-second data for a week or a month, and then maybe you start rolling it up to hourly averages or even daily averages as time goes on to reduce the amount of data you're storing. Wavefront doesn't do that. It keeps the data at the original resolution that you sent it. It means that if you're trying to compare what's happening today versus last month, or what's happening today versus last year, like for a retailer, comparing today's Black Friday behavior to what happened last Black Friday with the original resolution of the data is really important. We also have the ability to query data out really fast. So like those customers that are ingesting on the order of 2 million data points per second tend to be querying out of the system on the order of 10 to 30 million points per second. So we regularly see data being queried out at about 10x the rate that it's being queried in. The query language itself, as we'll see a lot in this training, and I already mentioned this is somewhat of the core of Wavefront, it allows you to really flexibly and powerfully define how you want your data to look. What use case are you trying to accomplish when you're analyzing the time series that you're working with? And that ties in directly to intelligent alerting. The way that alerting works in Wavefront is via the same query language. So you have one system and one tool for both visualizing and alerting over your data, which is pretty nice. I see in a lot of systems, visualizing the data and alerting over the data are fairly separate things. You kind of have to learn two different concepts. They often have different capabilities. So sometimes you might be visualizing something and wish that you had a feature from the alerting side and vice versa. In Wavefront, they're unified together very nicely. So anything that you can do with the query language, you can use to drive alerts. And finally, with the single pane of glass, this is kind of the idea of trying to bring together more observability primitives into one tool, which frankly the whole industry is doing this, like Datadog's doing it too, and other vendors. But the concept of being more than just a metrics tool, having tracing and other components of a complete observability stack in one place. We kind of saw this already in the demo, but just to reiterate, when we talk about metrics in Wavefront and we talk about time series, this is really the kind of data that we mean. It is numeric values that are varying over time. And it's generally fairly continuous. So you see that in this example, there are 4 lines and they're all reporting continuously across time. What we do sometimes see is data that really is more like events. Like say there was an attribute on this data like request ID, and that was a unique ID for every request that came in. If we then graphed that data, we wouldn't see continuous lines like we see here. We would see like one-off data points where that request ID happened one time and one time only. And so instead of lines, there'd be a whole bunch of dots across the screen. If you're using tracing within Wavefront, then certainly you can trace individual requests. That's kind of the whole point of tracing. But on the metric side of things, the whole system is really geared up for measuring more continuous time series like this, as opposed to events. Although there obviously, as the world becomes more and more ephemeral and change is becoming more and more rapid, we do see plenty of fairly short-lived time series. And it's one of the things that the product is pretty strong at dealing with, especially things like Kubernetes and containers in general, where in the past, a physical host might have existed for 6 months or even several years, versus a container, which may at times only live for a few minutes. Okay, so let's get into Wavefront itself, and please feel free to follow along at this point and log into these things if you haven't already to see how they work. I'm going to show here just where you access Wavefront, how you can set up some individual options for your own use of Wavefront, and we'll also look a little at permissions in Wavefront and how the APIs work. On the permissions piece, I'll be showing some things that only admin users can see, so that those UI elements may not actually apply or be visible to everyone on the call. But I still think it's important that you have some awareness of how those things all fit together. I've gone into Cloud Health now. I won't spend a lot of time on the top menu. We'll be seeing different pieces of this over the course of this week. But just to give you a quick sense, at the top, you have dashboards. This is where you can access your favorited dashboards, recent ones, and also go in and search for any dashboards that you like. Per a conversation that was had on Slack earlier today, we will be adding a quick search box here too. Alerts, hopefully self-explanatory. That's where you go in and look at both currently firing alerts, and it looks like there are 2 alerts currently firing here on Cloud Health at the moment, but also search for alerts, modify them, and so on. We'll be looking at integrations shortly. This is the single place or one-stop shop for finding if there's a pre-built integration for Wavefront or not. Under browse, in some ways I would say this is like a collect the other stuff that doesn't warrant having its own top level link appears under browse. So from here I can search for metrics, I can search for sources, but other things too, like events, maintenance windows, and so on. Applications is the newest one. This is essentially where the tracing features expose themselves. And I do believe that Cloud Health has got some traces already, but I haven't had a look yet.
While we're waiting for that to load, there's a question from one of the people, is there a mechanism or roll-up to drill down on individual metrics as you go through it, once you're done talking about what tracing is and how tracing works?
Yes, I'm going to be going through that in some detail. Yeah. So stay tuned for that. And yes, it took a few seconds to load, but yes, I see that there's some traces here. If you are not using tracing directly yet, you actually do get access to a demo tracing app that disappears automatically once you send your real data. So if you're interested to explore it, no matter what Wavefront tenant you're on, if you click here, you'll be able to see it.
Can you describe what tracing is and what people use it for?
So tracing, we talked quite a bit already about the kind of data that is generally sent into Wavefront. It's metric data. The kind of analogy that we have used for what people use metric data for, just so I can compare that to tracing, is it's kind of like a pilot flying a plane. They have all these dials and instruments, altitude, direction, and they have hundreds of dials in there, right? These are kind of like metrics. They are the instruments and key KPIs that the pilot looks at and uses to help fly the plane in real time. But they don't give a lot of context about how the plane actually works. So if you were not a pilot, but you're an aeronautical engineer and you need to understand how all those systems were interacting with one another, there's no real sense of that from the metrics. So that's actually, I don't know the Cloud Health one, so hopefully this makes some sense to look into. But tracing is all about understanding how requests actually flow through your system and how each request calls another, so that you can see hotspots in your code, like where are things getting slow. These are all the services that make up this US1 prod application. I can see a couple of things here. I'll actually click the details first. This is going to show metrics. So this is kind of a high level auto-generated picture of this service. And again, a bit like the pilot using the plane or flying the plane, here's the metrics that let you quickly see what's going on with it. I can see that in this case, there's a couple of requests involved, and this one is a lot slower than the other. I can click into this one and see the traces. Oh, of course, I could if there were some live ones. Let me see if I can find some. I don't know if anyone's on the call that can tell me a better one to look at for your data. Actually, let me do it this way. I'll just go to all traces, and this should show me something. Oh, here we go. So now we can see, I just kind of clicked through it to find the first one in the list. But I can see here how this service calls other services. In this case, it's just a simple linked chain, but this might be more complex. You know, this top-level service might call multiple things in order to get its job done, and you'd be able to see from here which piece of it is taking the longest. And in fact, it was a random one I clicked on, but this one is kind of interesting. You can see that the overall thing is taking 6.85 seconds, but really the entire time, and you can see this kind of critical path being highlighted by the orange band, is in this last service that it calls. So of the 6.85 seconds, 6.81 is entirely in this one service. From here, I can also see individual tags and detail about this request. Again, the big difference between tracing and metrics is twofold. One is tracing gives you this kind of end-to-end view of how things flow through the system, which you can kind of get from metrics, but it's not really directly what they're for. But also, unlike metrics, traces are the place where you can store a huge amount of very detailed individual information about individual events. Again, as I said, the idea with metrics is not to have unique identifiers on the things, because with metrics, you're trying to trend something continuous that happens over time. Whereas with traces like this, you actually are tracking individual requests and individual events that happened. Did that help, Scott?
Yep, I think so.
All right. And I will come back to that question about browsing for individual metrics and so on. So there'll be quite a bit on that. But I wanted to highlight, before getting in there, some of the general options that you can set for yourself on Wavefront. And I know some of you have already looked here, but for anyone that hasn't, a lot of the settings appear under your email. I'm actually logged in here as a user called dev@wavefront.com. So this is the kind of internal mechanism by which Wavefront customer success people can reach customer tenants. You're going to see your own email here. And if you click into it, you'll see the various options that you can set for yourself. I'm using the light theme for these trainings, but you can switch to a dark theme if you prefer. I would actually point out, in case anyone has got this set to V1, so everything that I'm going to show in this training is going to be around the V2 UI. We have set cloudhealth.wavefront.com to default to V2. So if you've never used Wavefront before, you're going to see V2 without doing anything. But if you happen to have V1 explicitly set here, then it will stay as V1 until you change it. We're not overriding what you've set there. It's not necessarily a bad thing to be on V1 if there's things that you like there, but I'm going to be using V2 for everything you see in the training. You'll see here, query display. This is what do you want your default query editor to be. I have set mine to what we call the advanced query editor. This is where you type queries directly. By default, it's going to be set to Chart Builder, which is the point and click way of building queries. During this week, I'm going to show Chart Builder and how it works. It's hopefully fairly self-explanatory, but a lot of the examples that I'll show will be via me typing the query directly in the query editor. And that'll either be for one of two reasons. One, with typing the query directly, you can do more things. Like the idea of the chart builder is a quick and simple way to do the most common use cases. The query editor can do other things. But also just I'm used to typing the queries. And so for my own sake, I'll use that a lot for the training. I have found with a lot of users that I've worked with, I said we default to the chart builder. They do tend to use that initially. They often want to switch to the query editor as they learn the language and get familiar with it. So if you get to that point yourself, this is the place where you would find it. This is a brand new one, by the way, this sampling thing. This has actually come up with Cloud Health before. I think I remember discussing this with people and explaining that this feature was coming soon, and it's here now. A lot of users ran into this issue of going into the metrics browser, looking up a metric, and it tried to graph, because you're just clicking a metric, it had no filters on it. It was trying to graph everything that's reporting that metric, and it might be thousands and thousands of lines, and it was bogging down your browsers and just being slow to render. What we're doing now is, by default, we're sampling the data. And you can turn it off on a per query basis too, as you'll see. But the idea is if you graph something and it has more than 100 time series, by default, it's just going to show you 100 random ones, so that the chart hopefully loads much faster. And then if you know exactly what you want to see, you can switch that sampling off. I think it probably makes sense to leave it on as a default here. The reason we've exposed it here is if you just want to turn it off all the time and never have it happen, this is the place where you could do it. I want to show, this is the piece actually where not every user will have access to this. And this might, let me see, this might ask me to re-off. Yes. So you're going to see a kind of sneak peek of how Wavefront does this behind the scenes. Regular Wavefront logins last for 7 days. So once you've gone on to Workspace ONE, you've logged into Wavefront, you should not be asked to re-authenticate for 7 days. The session timeout for looking at admin type features is much less than that, which is why it just asked me to re-authenticate there. I wanted to point out that with permissions, they can be assigned either to individual users or to groups of users. Every user in Wavefront is always belonging to the everyone group. So what I could see actually is Cloud Health does not currently have any custom groups that it's set up yet. If you wished to have types of user, like devs, or read-only users, various, whatever made sense, you could set up the groups here and have the permissions that make sense assigned to those groups. The way you have it set up currently is everyone has access to pretty much all features, except the ability to modify the permissions of other users. The batch query priority one is not assigned. This is not one that you want to assign to yourself generally. This is one that will actually cause any queries run by that user to be run at a lower priority than others. This is mostly only used for service accounts that are running like batch export jobs. So that the jobs, the query export jobs being run by those service accounts are nice on the system and don't impact real-time queries from users. The permissions here are broad-grained ones. So if a user has the ability to edit dashboards, if no dashboard specific access control is added, then that user can both create dashboards and edit any dashboards. If they don't have this permission, they won't be able to edit dashboards at all. They'll still be able to view them, but not edit them. Same goes for the other entities here, like alerts and so on. Both alerts and dashboards do have the concept of fine-grained control, which we'll look at in more detail on day 3. But for both of these entities, you can, and this is where you also may want to have groups. Like you can define that for this set of alerts, users in the dev group can edit them. Other groups can only view them, or things of that nature. For anyone that has the account management permission, it's in here where you can search for individual users and modify permissions on an individual basis. And just to show you, if I filter this down to the list of users that have that permission, this is the current list. While we're here, I'll also highlight that this is where you see the API documentation. Under the gear icon, we use a tool called Swagger to generate the documentation. It's pretty nice because it provides both a nice view of the doc itself, where you can kind of click through and see everything, but it also provides a way of actually trying that API directly from here, which is pretty neat. Once you've run an API call here, you can also grab a link to how you can run that with curl and things like that. You will find, or you may find, there's a small number of APIs that the product uses that are not documented here. If you ever do want to see like what the user interface is doing, and you couldn't find the API here, or even the API is here and you just want to see an example of what the Wavefront, how the Wavefront user interface is using it, then I suggest using dev tools within your browser. Makes it pretty easy to see exactly what query is happening and copy it from there. I'll also just give a shout out to this tool. And I'll include a link to this in the presentation material so you have it. This is a CLI for Wavefront built around that API that I just showed you. It's actually created by a customer of Wavefront, but they maintain it very conscientiously. And it's pretty nice. I use this quite a lot myself, and I know a bunch of other people that use it. If you're the type of person that ever wants to make little bash scripts or things like that to automate stuff around a tool like Wavefront, obviously the API is pretty simple, so you can write your scripts against the API directly, but this CLI makes it pretty quick and easy to write those kind of things. In fact, I don't know if you remember, Scott, but yesterday I sent you a list of all the sources that we're reporting currently. I used this tool to run that query and export it as a list.
Cool.
If you are a new user, you will see this page when you first log in. It does have some helpful information on it, so by all means click through it and take a look at the content that it's showing you. If you want to remove it though, click the don't show getting started again. Not that it hurts anything, but I have noticed with a lot of users, they'll have this getting started 100% thing, and it's just taking up space in their top menu, like forever forward. Doesn't hurt anything, but if you want to get rid of it, just click into it, and you can check the box, don't show getting started again, and you're good to go from there. Okay, user profile is what we looked at. Okay. So now we're going to look at how data gets into Wavefront and a bit more detail at the data format of Wavefront. And Cloud Health's use case is pretty interesting here. This could be a good place to have a bit of discussion about how you're using Datadog, agent, and things like that. So this slide is speaking to all of the various ways that you can get data into Wavefront. It doesn't specifically highlight Datadog agent, but data coming from agents is certainly the one main way of getting data through. Most data that comes into Wavefront does so via the Wavefront proxy. And Cloud Health is itself using Wavefront proxy. This is not strictly required. Like the exact same data format that you send to the proxy, you can directly send to Wavefront itself, which we call direct data ingestion. We generally recommend using the proxy in production just because it provides a nice queuing point for data. So if you send data to the proxy and the proxy cannot send it to Wavefront, either because of a networking issue, or even if Wavefront was having an issue, or if you were trying to send data at a higher rate than your rate limit, and Wavefront was therefore pushing back on the proxy and telling it to queue up data, the proxy will keep that data locally. It'll keep retrying it and keep trying to send it, and so you won't have any data loss. Like the network comes back, all the data that was queuing up will flow across to Wavefront, and you'll be able to see that data in your charts as if there was never any issue. You could, even with direct data ingestion, if you wanted to, you could, if you don't get a 200 response code, you can write your own retry logic and all that stuff, but why bother when the Wavefront proxy does that for you? It has some other nice features that I'm not sure if Cloud Health has needed yet, but it has a pretty extensive preprocessor rule framework that allows you to modify metrics as they're flowing through, add tags, remove tags, rename data, which can be particularly handy if you're not in control of the thing that's sending the data, but you want to massage it or modify it in some way. I kind of look at data coming into Wavefront in three main ways. Like I'll talk to logs maybe at the end. So agents tend to be data where you are not the data that's running locally to you, but you are not the owner of that data. So agents are typically used for collecting infrastructure metrics like CPU, memory, disk, things of that nature. But they can also and are commonly used for collecting application level data as well, but for applications that you didn't write yourself. So like agents will often have plugins for software like MySQL or Apache or literally hundreds of other things. And so the agent is used to collect data from things that you don't directly control, your infrastructure and common pieces of software that you're using. The standard agent that Wavefront suggests to use, although it's a bit of a soft suggestion, is to use Telegraph. It's an open source agent. It's pretty popular. It's pretty actively developed, which is nice. So there's both lots of new plugins coming all the time, as well as improvements to existing plugins. So our message is kind of, if you're not already collecting metric data, we suggest you use Telegraph. We think it's a good agent. But we're pretty open and flexible. This is, I think, a big difference between Wavefront and Datadog, in that Datadog, although you can send custom metrics, of course, to Datadog, I would say its focus is kind of around its own agent, and it kind of pushes you in the direction of only using its own agent. Whereas in Wavefront, we treat everything as just a metric, whether it came from Telegraph or it came from your code or it came from anywhere else. It's all just metric data to us. So we're not so prescriptive about where it has to come from. So as well as the Datadog agent, which Cloud Health is using to send data, a lot of our customers are using other pretty common agents like Collectd, Diamond, and others like that. T-Collector from the OpenTSDB project. The other place where you get a lot of data that you don't directly own from is cloud providers if you're using them. So if you're running on AWS, GCP, or Azure, I'm pretty sure Cloud Health is all three of those. We have pre-built integrations to pull data directly out of those cloud providers' metrics tools. So kind of the difference between agents and cloud providers is, with the agent, you are running something yourself locally. Even if the agent is running on a cloud like EC2, an Amazon EC2 instance, you're still choosing to run an agent on that instance. With the cloud support, you're getting data directly from the cloud provider by configuring that in Wavefront and not running anything locally yourself. The third big way that we see a lot of data coming into Wavefront is via instrumenting your own code. In Cloud Health's case, I believe that you are using DogStatsD for code instrumentation, and those metrics are coming through to Wavefront via the Wavefront Datadog integration in the proxy. And I think that's fine. I don't expect that you would need to change that, actually, or probably even want to change that, since you've probably spent a lot of time and energy instrumenting the code base already. But Wavefront does have its own SDKs. If you are familiar with, there's a code library that's gone through a lot of naming changes over the years, but you might be familiar with either Coda-Hail metrics or Yammer metrics or Drop Wizard metrics, which is the latest name for that library. The Wavefront SDKs are built around those libraries. That library originated as a Java code instrumentation library, but was quite popular and has been ported to all kinds of different languages. The Wavefront SDKs are all based around that style of collecting metrics. Very similar concepts to the StatsD concepts, though, that you get in DogStatsD. And then, go ahead. I think there might have been a question there.
Yeah, I wanted to basically make a statement and just to make sure everybody's aware, and then to just ask you to expound on it a little bit. So as we've done the integration with Cloud Health's environment to Wavefront, we've chosen to continue using the Datadog proxies, right? And that's mostly because if we switched to Terraform, it would have changed a lot of the metrics that we currently collect. So that's one thing, and it'd be great if you could call out at some point in the training, maybe not today, but one of these days, what that actually means to what features we can use in Wavefront at this point and which ones we cannot.
Okay, yep.
The second thing that I'd like to point out is we've pushed a lot of metrics into Datadog, and it get very expensive with very high cardinality data, right? So ones that you put like user IDs and that sort of stuff in there. As I understand it, that is not an issue with Wavefront. So sending high cardinality data points is actually a good thing, but Connor, you can expand on that, if you would.
Okay, yeah, I'll cover both of those. Sounds good. Thanks.
And the last one that was on the chat is there a hookup for CloudWatch events into Wavefront?
Do you know, do you specifically mean events from like CloudTrail, or do you mean metrics from CloudWatch? or both, perhaps.
Natalie, which one do you mean? If I don't get an answer, I'll go with both.
All right. So
you got it, Scott. Thank you.
the AWS integration does pull data out of CloudWatch. It's getting an overhaul at the present time. This is not shipped yet, but I hope that it will be shipped fairly soon. A while back, AWS actually improved its CloudWatch API. Wavefront is currently still using the older CloudWatch API. We're switching to the newer one. But in both cases, it's pulling all data out of CloudWatch. A limitation that I think that the Cloud Health team has already run into in comparison to the Datadog integration, which is I'm hoping it will be fixed when we're switching to this new API, is that currently Wavefront is only pulling AWS resource tags from EC2 and EBS. Obviously in AWS you can have tags on, maybe it is literally everything at this point, but certainly you can have tags on lots of things, on ELBs and all kinds of stuff. And our integration is currently not able to pull those tags out. That's something I hope to see improved. With events, we do integrate with CloudTrail as well for pulling events out. Like in that demo I showed earlier, I'd shown this little event symbol on the chart where I marked where we did a code update at that point in time. So we can pull events out of CloudTrail like that, which are not metric data or not time series data. Those are also limited right now to they're basically CRUD EC2 events. So like start instance, stop instance, added tags on an instance, things like that. So there's some support for CloudTrail events, but it's fairly limited at this point. It was listed as number 2, but I left it off for, I described it later. You can get logs into Wavefront too. So fundamentally, Wavefront is not a logging platform. Like it's all about this time series and metric data that we showed. It's not about sending individual log lines into the system. But it is possible to parse metrics out of logs. Like say you have a log that has a timestamp at the beginning. It lists out an API call that was hit. It lists what the response code from that API was. It lists how long that API took to run. And maybe it then lists a whole bunch of stuff. Like maybe there was actually an error and it lists a stack trace about what that error was and things like that. You're not going to send all that data as is into Wavefront, and you're not going to send the stack trace into Wavefront unless you're doing trace logs, which we talked about briefly earlier. But you could parse out from a log like that. You can parse out how long did the request take. You could turn that into a metric. You can parse out what was the response code. So you could turn that into a count of how many of those response codes did you see over time and turn that into a metric. And there are facilities within the Wavefront proxy for defining the rules by which you would extract metrics from logs. We use, basically it's Grok. If you ever used Grok, which is part of the ELK stack before, it's that same language that we use to specify how you're going to extract and match data out of logs into Wavefront. I left that to the last only because it does take a bit of, even from the description I provided, you can probably tell, it does take a bit of configuration to set that up. Like agents tend to be, you just turn them on, they tend to have a bunch of default plugins that just start sending data. And sure, you might tweak the configuration and whatnot, but they give you a lot of data in a very turnkey way. The log ingestion feature is really more about, I'm going to configure precise rules for how to extract metrics out of my logs. The other that's listed here, this is actually very similar to agents, I would say. I guess it's highlighted here separately on the PPT here, but this is about getting telemetry out of other like VMware frameworks and infrastructure platforms like vSphere, Pivotal Cloud Foundry, and so on. In some cases, we have implemented support for these things literally as Telegraph plugins, in which case number 5 literally is the same as number 1. It's using the same agent. And that would be the case, for instance, with the vSphere Telegraph plugin. And there's also a vSAN Telegraph plugin. With PCF, PCF has its own framework for how to extract data out of it, which involves implementing PCF brokers and things like that. So in the PCF case, we've implemented a custom PCF broker as opposed to a Telegraph plugin. But the concept is very similar. Now, to your first question, Scott, about what impact does using Datadog agent have? Well, I will say that, I mean, this is perhaps besides or outside of the scope of the training. It does have an impact in the sense that working together, we are identifying some gaps in the way that, or differences in the way that the Wavefront proxy is interpreting the data that Datadog is sending compared to how Datadog server does it. So we're going to have to work together to tweak the Wavefront proxy to accommodate those. So it has an impact there, and there's a little bit of upfront work we're going to have to do to make it work nicely. But on a go-forward basis, I think really the only impact is Wavefront has a whole bunch of out-of-the-box integrations, as does Datadog. Most or all of these integrations come with one or more pre-built dashboards, and those dashboards, most of these integrations, as I've said, are based on Telegraph plugins. So most of those pre-built dashboards are expecting the Telegraph metric name to be in there. And if you're sending data from the Datadog agent, the names are not going to match, and the pre-built dashboards are not going to work. I don't necessarily think that's a major problem for you, because I know that you are working on and trying to migrate as much of your existing content as you can anyway. And if you already have custom built dashboards around any of these things, then those are going to be better and more closely tuned to Cloud Health's actual needs than any pre-built dashboard would be anyway. But that is the caveat. Our pre-built integrations are generally targeting Telegraph, and so they won't work if you're sending the data from Datadog. And we can actually get in here to the second question you had about Datadog as well. In terms of cardinality and so on, there's be a slide coming up after this one that will focus on cardinality specifically. We can even highlight it here too. This is what a metric, in fact, this is the Wavefront data format. This is both what metrics look like in Wavefront, but this is literally the data format too. It's a line-orientated, space-separated format, beginning with the metric name. We tend to use in Wavefront, by the way, and this is something I've seen in the Cloud Health data where you don't always have dots as your separator. I've seen dashes and things. Wavefront tends to use dot as its separator. The dot then forms almost like a tree. If you think of just looking at a file system, the dot separated pieces you can think of as drilling into a file system. Like under aws.elb, you're going to have other, request count and other things besides latency. Everything is numeric, so all the values are the numeric value at the point in time you took the measurement. Timestamp is in Unix epoch seconds. The minimum granularity is 1 second. So if you really wanted to, you could send a new value every second. Most people don't. But And it is also flexible, though. I know there are some time series systems where you kind of have to standardize on an interval, like we're going to emit everything at a 30-second interval or everything at a 60-second interval. That's not the case in Wavefront. For something that was critical, you could emit the data every 10 seconds. Something that's less important, you could emit every 1 minute or even every 5 minutes if you wanted to. You can chop and change as needed. There is one tag which is always present in Wavefront. We call it the source. This is the thing that is emitting the measurement. It's very often a host name, but it doesn't have to be a host name. It could be the name of a service, or like just hypothetically, like the kind of canonical example of time series data is stock market data. So it could even be a stock ticker symbol or something like that. I'll point out, this is interchangeable with host in Wavefront. So we tend to call this source, but you can also call it host. And you can, they're synonyms of each other in Wavefront. You can just use either. So even if you ingested the data with source equals, you can query it back later, filtering for this thing by host equals and vice versa. It's a little bit of a historic accident in that host is what we originally called this, and even today it is very often a host name, but we had a lot of customers using it to track things like names of services or other entities, and they wanted us to make this a more generic name, so we picked source, but we kept host for backwards compatibility reasons, so you can use either. This is where you generally get into cardinality then. You can have optional key value pairs that give additional metadata on the time series. You don't have to send these, but I would say on most data that most customers are sending, they generally have some point tags. You can name the key value pairs whatever you want. It's not shown in this example, but I would suggest wrapping the values in quotes. If you do that, then the values can have spaces or strange characters in them. Because the data format is space separated, unless you wrap in quotes, it won't work if you have spaces. You can kind of see here, in fact, there's probably a better slide to highlight this. Yeah, this is a good slide to kind of see. A time series in Wavefront is the unique combination of the metric name, the source name, and any point tags that are on the data. So we can see, looking at this chart, we're looking over a time window, and we see that at a certain point around 5 p.m., the line changes color. That is because this is a different time series, and it's showing below the differences here. The metric name is the same, dev.request.latency. Source is the same, both app5. Some of the tags are the same. On both of them, they have environment equals dev, but then the version tag has changed. Because there is a different value of one of those things, metric name, source name, point tags, this results in two different time series. This is what I was partially what I was getting at when I showed the version tracking demo earlier. I personally kind of like the idea of tracking version numbers as a separate metric. That way, the thing I'm measuring, like latency, is just a continuous thing that happens over time, and my versions may change independently of that. But the way it's done here, I do see very commonly across our customers with version being tracked as a point tag, which leads to multiple time series. This also really defines what we mean by cardinality. If there were multiple versions reporting at the same time, or multiple like account IDs from an AWS standpoint reporting at the same time, then if I graph this data, like I graph AWS ELB latency from source equals labs VPC, I may get multiple lines back. And that is what Wavefront treats as the cardinality of the data. There is no special cost for cardinality in Wavefront. So as you're ingesting data to Wavefront, we're just tracking. This is what we call a point. We're counting how many of these points we see. This is one point, whether it has several point tags on it, like this case, or no point tags on it. It's all still 1 point. We just count those up. We look at the rate per second at which they're coming into the system, and that's how cost and charging for Wavefront works. So cardinality doesn't play into it at all. We do still, and the system is designed to handle cardinality as best as it can, but we still do recommend, I mentioned this earlier, the aim of it is you are trying to measure continuous things over time. If you were to send a unique value on each and every point tag, or even like would be worse in the metric name, like you had a request ID, say you had AWS ELB request ID .latency, then you would no longer have time series, you'd have individual events. And while there wouldn't be any special cost associated with that, it would not perform well. The system is not designed for handling individual events where every metric is completely unique. That makes sense, Scott?
Yep.
This will touch on that even a little more. There's some best practices around naming things that I think are useful to know about. We just talked about cardinality, and we talked about having unique things in the data. It is sometimes unavoidable, and as the industry we're all working in moves forward, it's becoming ever more unavoidable. Like you will have things like container IDs, pod names and stuff that are quite ephemeral, and they may last for a while, but they're not going to last forever. Where possible, we suggest to put those in a point tag value. It's best to keep, if you're going to have high cardinality, it's going to perform best if they are point tags. The worst place to put that kind of high cardinality stuff is in the metric name. We suggest that you keep the metric names as simple and static as possible, and then have the unique stuff as point tags, which hopefully makes sense. We do suggest using delimiters. In fact, the reason why we suggest making the metric name be the most static thing is that we maintain within Wavefront trigram indices across all metric names. These are the indices that allow you to search for metrics, and you can search for metrics. You don't have to know the beginning of the metric name. You can search within a metric to find it. The indices that we maintain to facilitate that need to be updated when new metrics hit the system. So if you're constantly adding brand new metrics with unique names in them, we're constantly doing that indexing work, and it can impact performance. Also, based on how those indexes work, they perform better if there is some separation in the metric name. So rather than having one big long name with no delimiter in it, it's better to split it up if you can. You are able to put wildcards in your queries. Like say we were doing a query here and you wanted to see all the percentiles, not just the 95th. There could be an asterisk here, this part in the query, and then it would show you the 95th, the 99th, 50th, whatever else was reporting. It will perform best if you put those wildcards between delimiters like that. So the case here where it would be like dot star dot is pretty ideal. You don't have to do it that way. You could just do dot star and it would match 95.daily, 99.daily, and so on. But for best performance, if you can put your wildcard between a delimiter, that's good. The other thing to try and avoid, if you can, is try and avoid having delimiters right at the start. Like if I had a wildcard here, like star.metric.percentile, the system kind of has to look at all of the metrics to see which start with or which end in the match that you have. So if possible, avoid putting wildcards at the beginning of your queries for best performance. Nothing to stop you doing any of these things, and it often might work just fine, but I am suggesting the best practices. This speaks to cardinality even more directly than what I said previously. This has improved a little recently. We've made a recent change to make the system smarter about how it deals with cardinality, but we still have this recommendation, and I suspect that we will just stick with this recommendation as it's a good rule of thumb to live by, even though we're making the system smarter as we go forward. And the recommendation is this: Wavefront internally treats the combination of a metric and a source as a time series in the way that it internally stores the data. So in that previous example, or the data we were looking at, we had dev requests latency as the metric and app5 as the source. That is a time series. If I graph that, if I graph dev request latency filtered to app5, although there's two time series over time here, there's basically just one time series at any given time. It has two tags on it, but the cardinality is 1 because the two tags are constant for the metric and source. And so the rule of thumb is if I graph a metric filtered to a specific source, we suggest to have 1,000 or less time series be returned as from that query for best performance. Again, just like the previous best practices that I mentioned, it's not a hard and fast rule. Nothing will break if you go above that. And in many cases, it might actually work okay. Even internally to Wavefront, we have some data that breaks this convention, and it works quite well. But it's sort of a rule of thumb to have in mind when you're thinking about how to model your data. Change that we have made recently is that previously all data was stored internally as the metric and the source, and any other point tag values were sharded around that metric source combination. Nowadays, we have an algorithm or a piece of the system in place which is just continuously inspecting the actual data shape. And if it sees other dimensions that it would be more optimal to include in how it shards the data, it will include them. So this rule is actually gotten relaxed over time, where it can handle cardinality even better than this. But we keep it as a rule of thumb. It's still a best practice to keep in mind. Hope that makes sense. I won't demonstrate this tool today, but I will include the link in the presentation material. And I encourage anyone that has any concern about the data rate, like this may not be of interest to every user, but if you are the person that gets billed for Wavefront and you want to know like which metrics are emitting the most data, which metrics are we maybe emitting a lot of data from, but we're not actually querying the data very much, so it's maybe not very useful data to us. This tool can help you find that kind of information out. It's built around there's an API in the product that basically just lets you see a live tail log of the data points as they come into the system. This tool just sits on top of that API and lets you look at some stats about the live data as it's flowing in. Can be pretty helpful. All right, so let's look at browsing the metrics in Wavefront. This is something that was asked earlier in the call, and I promised to get to. And here, by the way, this is the WF top tool. Links in the PowerPoint to take a look at it. There's several different ways that you can look for data. I'll show them all. I have to say that my most common way, but it may not be the most obvious as a new user, is I mostly go to a blank chart. In fact, I've seen a lot of Wavefront customers where this URL, they just bookmark it. And if they ever want to just get to a scratch pad, they just go to their bookmark and they start typing a query. Reason why I say that is, I'll come back to this later to show more detail, but this thing will auto-complete your metrics for you anyway. So it almost is in of itself a way of exploring your data and exploring what metrics exist. And I use this the most often. What most users find the first, which is good, I mean, it's intended for this, is the ability to browse and search for metrics. I have noticed some things about the Cloud Health data that make this metrics browser a little tricky. Even this ties back directly to the previous discussion that we just had about best practices for naming metrics and so on. You do have plenty of metrics that these may not be very ephemeral. I'm not sure that the rate at which these are being created is posing any kind of issue performance-wise. But you do have a lot of very unique metric names, which makes the metrics browser pretty hard to use to see like a nice, clean-looking hierarchy of metrics from which you can click in and explore. There's a feature by which you can hide metrics from here. I actually did hide several yesterday as I was preparing for this training. There were other metrics that begin with like 0 or 1 or 2, and I hid them. This feature only works on prefixes, so it's like you can hide based on the prefix of the metric name. Unfortunately, it does not support anything like regular expressions or something like that, and therefore I couldn't hide these ones. So I actually had a discussion with folks from the Cloud Health team about this. I think this is something that you will probably clean up over time. And I think we're all in agreement about how to best name metrics. If you stop emitting metrics, they will gradually disappear from this list automatically. So there's a cycle looking at this data to see whether it's actually recent or not. And within about 4 to 6 weeks, if a metric stops reporting, it'll automatically drop out of the list. The Manage Hidden Metrics button is a way to make that happen like right now without waiting. I can search for metrics here, and indeed I can search for a source and see the metrics that source is reporting. I remember seeing some examples here. Yeah, so like, let's look at this, for instance, system IO await. This is where the sampling feature that I mentioned earlier comes into play. So I don't know if you called it, but as I started to load that data, there was a progress meter that said something in the range of 8,000 time series under the covers that the system is having to look at. That progress indicator doesn't necessarily mean that that system is reporting that data within this 2-hour time window that we're looking at right now, but it does mean that it was reported within the recent past. I'm curious to see whether this sampling feature solves some of the problems that I know the Cloud Health users were having in looking for data, because the difference now is that this did not try and graph all 8,000 lines. It just filtered it down to 100 lines so I can get a sense of what the data looks like. If I really want to turn this off and see everything, I can, but I'm probably going to do that only after I have filtered the data down more. Like, I'll be showing more exactly how the query language works, but let's say I filter this to drill down database only. And you can see when I ran that, there was no message saying that the data was filtered, because there were less than 100 lines in this query anyway. So let me know how that goes. I'm certainly curious to hear, and the Wavefront PM team would also be curious to hear whether this sampling change has helped with that discoverability issue that you were having. The other place where you can look for metrics is under sources. This is kind of the entry point to searching for a source, but from here you can also then drill into what metrics is that source reporting. There were questions that came up about this, I think it was yesterday, so I'll spend a little time here to show you some of the things you can do. By default, it's just showing you a list of all the sources it's seen, alphabetically sorted. If I want to only see things that have reported data recently, I can filter them like that. If I want to see older stuff, I can do so. Obsolete are ones that did not report in the last 4 weeks. Metrics stopped are ones that haven't reported in the last day or so, but did report within the last 4 weeks. It's also possible to, actually, you know what, to make sure I explain that clearly, because Cloud Health is using this feature. I'm pointing out there that you can group sources together as well using something that we call source tags. And this has become an interesting challenge with Cloud Health as you're migrating with Datadog. So we're looking at this data here and we see these point tags on the data. These dimensions are literally attached to this metric and this source at this timestamp. If I then graph another metric that is being reported by the labs-VPC source and it doesn't have these point tags on the data, then I'm not going to see those tags and I'm not going to be able to access these tags in my query. So if these tags are really useful, most data in Wavefront has them, but it does have and actually sometimes it's a good thing, like the fact that these tags are associated with this data at this point in time means that if this thing somehow changed region to US West 2, I could be able to look at the data and see at this point in time, this is where this region tag changed value. However, this seems to behave a little differently from Datadog. The way, I'm not an expert on Datadog, but it appears to me that all the tags like this in Datadog actually get associated with the source or with the host. So that even if you're looking at a different metric that does not have or did not have these tags on the data, you'd still be able to see the tags because they were associated to the source. Wavefront does have a similar concept that we call source tags. So you can add tags to these sources, and you can then use those tags in your query filters, and you can use those tags on any metric that source is emitting. The difference is that those tags are not key value pairs. They're just simply strings that you attach to the source. Because they're not key value pairs, when you're querying for them or filtering for them in your queries, you always do so using tag equals. With a named tag like this, if you wanted to filter down to a specific account, the query filter would be account alias equals whatever account you want. With source tags, because they're not key value pairs, it's always tag equals. I hope that makes sense. I remembered about it when I saw here that Cloud Health is using this source tag concept. And it's doing this because when you're collecting data from the Datadog agent for instances that are reporting from AWS, the Datadog AWS integration was assigning a bunch of tags to that data. Those tags were not being sent by the Datadog agent, they're being assigned by the Datadog backend. And so assigning them as source tags in Wavefront is the mechanism by which you can attach those tags to the sources in Wavefront and then query for them across all the metrics being reported by that source. And you can see, hopefully these are recognizable to some of you as the Cloud Health source tag names. Interesting to see what this one actually reports. Okay, quite a bit. So I drilled into a source, and this is where I was saying this is from a source or from the source browser is another good place to explore your metrics. I clicked that source and I can see all the metrics that source is reporting. I can click any of them to build a quick little view of what the data looks like from that source. The system will do its best to try and track where that data is coming from, so I can filter it on to the Datadog agent ones like that. So hopefully that makes sense. Did that help Scott or anyone else with metric discoverability in general and how to find stuff?
Yep. Yeah, I think that helps, and it's important for the team to know because we really use the AWS tags to identify basically all of our infrastructure. So
yes,
that's kind of how they're showing up, and it's being put into the system via the Wavefront API at the time that the system runs its first chef run. So,
yes, that makes good sense. Yeah. Okay, final topic for today, and you've seen some queries, so we kind of touched on aspects of this already. The final topic for today is a preview of the Wavefront query language. Tomorrow is going to be a deeper dive into the language, and won't cover every single function, but we'll talk about a lot of the different categories of functions that are available. When I get back into the Wavefront product, I'm going to initially show you how to do this with the query builder. With the query builder, you don't even need to see the language at all. This might be a bit of a personal preference for myself. I personally like to, even if I was using the query builder, I personally like to have a sense of what it's doing under the covers. But query builder does its best to try and obfuscate all of this away. But queries are split into two main categories of thing. You see how it's highlighted in green, the base query, and then it's got the advanced functions wrapped around that. The base query is pretty much like, and it's not SQL, so I almost hesitate to say this, but it's like the select statement in SQL. This is the piece of the query that you're using to say, what data do I want to extract and how do I want to filter it? On top, and so, oftentimes that may actually be all you need. Like for all the powerful analytic capability that Wavefront has and all the functions you can apply on the data, it's most often that you just want to look at a bunch of data, look at it over a week and see how it's been trending. And you may not need any function for that. You may literally just want to graph the data. And that green part, the base query, is how you do that. In this case, it's filtering to one metric with no wildcard, although you could have wildcards in the metric name as well. It's filtered down to any source that begins with clusters. It's got a wildcard in there where it was coming from the production environment or env tag. Taking a look at how that works in the product. I'm going to use sample data here. So if you want to try this kind of thing out, this will work both on vmware.wavefront.com and cloudhealth.wavefront.com. You don't have to have a Cloud Health login to do this. You'll notice that when I create a blank chart, it defaults me to the typing the query directly. That's because of the setting that I had set for my user under my profile. In your case, you may well see that this query builder is the default. You can flip between them at any time by just clicking. The flipping is one direction only, at least for the time being, in that if I build a query with the query builder, I can flip to the query editor and see what the written language was for that query. If I don't change anything, I can flip back again. But if I do modify my query, the system isn't smart enough to know how to convert that back to the query builder view. Within the query builder, I either look for data within integrations, and this might be one, I didn't think of this earlier, Scott, but this might be one other place where using the Datadog agent might impact it a little bit, in that if everything was telegraph based and you were integrating, like I saw console as metrics in that source we just looked at. So you might see like console here because you were getting data from the telegraph console plugin, and this could help you find data from the integration that you were looking for. But you can also just browse. Again, with browsing, we run into that same challenge of there's a lot of very unique looking metric names in there. And I can also just search for metrics. As I said, I'm going to use just sample data to take a look here. All internal metrics in Wavefront begin with the tilde character. We'll be looking at some more of those over the course of this week. There's a lot of useful information in there. The ones that begin with tilde sample, it is literally that, just sample data, so that you can play around with the system even if you're not ingesting any of your own data. When I graph that, it's showing me anything that is reporting this data over the 2-hour time period that we're currently looking at. If I want, and actually let me show you how the legend works here too. If I hover over this data, you can see this hover legend populating over the left-hand side. It is doing its best to highlight where I'm currently hovering, or like which time series I'm currently looking at. You will notice that, and you'll probably see this coming up when you look at your own data. The legend does its best to try and present itself as compactly as it can. I'll show probably an example in a minute where some of the data is common to all of the series. In fact, let's do this. Let me filter down to one of the environments. And do you see how now, previously I saw these columns like environment equals production and AZ equals whatever, and those columns were shown like a table view. When I filtered to environment equals production, it happened to be the case that environment equals production and AZ equals US West 2 became common to all of the time series that I'm graphing. And so rather than displaying those in separate columns in the legend, it moved those up to the top part. And the legend is just generally trying to do that. It's trying to display itself with as little space as possible. If you do want to see a legend that's there all the time, there is a fixed legend as well that can be useful, especially on dashboards, to call out what is going on. You can have multiple filters. In the query builder, these filters are simple in that they just simply AND together. So I've got environment equals production and source equals app10. And then we'll be looking at the functions more tomorrow, but I can apply functions on top of this data from the query builder as well. Query builder is nice because it shows me the functions nicely categorized, shows me documentation of the functions, and kind of helps me find what I'm looking for. If I want to know like a 10-minute moving median of this data, I can apply that function like that. As I said, this is one way, but I can click, or at least one way once I've made an edit, I can click the button here and see the query language that's making up the query that I'm looking at. In fact, let me take a step back. If you do want to try writing queries directly, it's pretty simple. There's just a couple of things to remember, and then your knowledge can build from there. At its base, the system is basically like an old graphing calculator. Like if I type 0, I get a constant 0. This can actually be helpful sometimes. Like if I know that above 100 is a bad thing, and I just want to have some visual cue on my chart of when things go above 100, I can just write 100 like that. I can even color it and say, I want this to be red, and this is now like my boundary line or something like that. I can type standard SI notation to type big or small numbers quickly. So if I want to type 100,000, I can type it like that. I said it's kind of like an old graphing calculator, or people still use them, so maybe not so old. I don't know of much use for stuff like this necessarily, but just to show you that it's there, you can just do math and manipulate the time series as you want. Normally, you want to work with actual data that you've ingested, and the building block to that, and this is really one of the few things to remember. Building block is TS, which stands for time series, and then open paren. System will do its best to try and auto balance my parentheses for me. So I didn't have to type the closing one. I just opened it and it got it for me. And I can just start typing here and it will auto-complete metric names for me. Let's see, it should be able to search. It may not be searching the sample data within the metric name, actually, to avoid you always running into sample data when you're looking for your real data. But you can generally search within metric names here. I can graph this similar to what we did with the query builder. I can graph a bunch of stuff. I can put wildcards. So here I'm graphing anything that begins with sample.request.star. I can filter in the same way as I did before. By convention, we put a comma between the metric name and any other filters, but you actually can put and there if you want to. It's the same thing. I can filter down to a single app like that. Now we can see we've got the one source reporting 3 different metrics. I'm actually going to turn off the color since that's kind of funny. Let's pick one of the metrics and show you a couple of things. With the language, the filters can be as arbitrarily precise as you want. Like, let's say I want to graph everything beginning with app-1. This is matching app 1, app 10, app 11. I get those series appearing. We'll look more at functions tomorrow, but there is a function that can count how many time series exist in the chart. If I do this, I can see that there are 11 matching time series to the query that I'm running. This is something that you can't do in the query builder, but here with the language directly, I can say, I want app-1 star, but I don't want app 1 itself. And when I do that, the count changes from 11 to 10 because I'm filtering one of them out. Does that make sense? And any questions about kind of how this is working in general in terms of simple queries for your data? Or things that you've tried and haven't worked or anything like that? Okay. This is showing the chart builder, and then we're at the end of today's session. I'm going to paste this into Slack as well. I think for the subsequent days, I don't think there is even a slide for the exercises. We'll just put them directly into Slack. This is the exercise for today. It's pretty simple. And actually, for some of the Cloud Health users, you're already working with Datadog Agent and ingesting data into Wavefront. And so you've really done, you might not have done your laptop, but you've really done similar things to this. But for others that have never sent any data to Wavefront before, it's pretty simple to get data flowing from your own laptop or your own machine, whether it be Mac, Windows, or Linux. And so the suggestion is just to try that out. We're suggesting to do it on the sandbox. If you remember, I showed you on Workspace 1, there, as well as Cloud Health, there is a Wavefront sandbox there. So we're suggesting to do this exercise on the sandbox so that you don't pollute the Cloud Health, real Cloud Health data with your laptops and so on.
For more information, detailed videos, and blogs about all Aria Suite products, please visit apps-cloudmanagement.techzone.vmware.com or simply scan the QR code to learn more.